So at this point, we have learned the operations of addition, subtraction, scalar multiplication, and matrix multiplication. We talked about a lot of the properties, but these properties here really only involved matrix addition and subtraction. So how does that correlate when we want to talk about matrix multiplication? So I have my properties of multiplication listed here, and notice I very explicitly cross out the commutative one because you cannot rearrange the order of your matrix multiplication and get out the same answer. Notice that sometimes our dimensions didn't even match, so definitely we cannot switch the order. However, okay, our associative property is true assuming all of these are possible. Now, in some examples they will be because the dimensions are proper, and some of these they won't be because the dimensions aren't appropriate. Okay, so if our dimensions match, it doesn't matter if we multiply A times B first and then include C, or if I multiply B times C first and then include A. Distributive property still holds true, and notice I had to list it twice because on once I have the matrix multiplication on the left, and on the second I have the matrix multiplication on the right. So again, you think it doesn't matter, it doesn't make any difference. Yes, it does matter the order of matrix multiplication. So it holds true no matter whether our multiplication is on the left or on the right. And the last thing is our identity property, where if I multiply a matrix times our identity, remember that's ones on the diagonal and zeros every place else, that's where we're going to end up with the exact same matrix. So this identity is kind of like the 1 in our real number system. So 5 times 1 gives me 5. This is the 1 version of our matrix format, where it's ones on the diagonal and zeros every place else. Okay, so that's just an overcap of what properties hold true when we're talking about matrix multiplication and which ones don't hold true, specifically the commutative one. So the million-dollar question is, okay, well, I can figure out how to add, subtract, and multiply matrices, but why? What's the purpose? What is it good for? So let me show you an example of where we would see this in day-to-day life. So we have two of the items sold at a bakery are blueberry bagels and raisin bagels. So we have two tables listed below, gives the number of dozens of each of the bagels sold at each store. So this bakery has 3 different locations, one on Main Street, one on Ohio Street, and one on 12th Street. So we can see that all of this is summarized in a table. Okay. Well, in our first week, week 1, our Main Street sold 23 dozen blueberry bagels. Ohio Street sold 8 dozen of our raisin bagels, and so on and so forth. And we can do that same thing with week 2. In week 2, the 12th Street location sold 8 dozen of our blueberry bagels. Okay, well, if I were just to kind of ignore all of this extra operations, all of this extra information out here, I would have a matrix from this table. Same thing with week 2. If I were ignoring all my extra information, this here would give me a matrix. Well, we want to know, how does this compare? If I just want to do week 1 and week 2, and I want to know the total number of each of these at each location, well, then I would just add my 2 matrices, hence matrix addition. Okay, so total number of each item at each store. So I want to keep everything respective. And so basically, if this was my matrix A and this was my matrix B, I would just be adding matrix A plus B. So here is an example of where matrix addition comes useful in day-to-day life. So I have 23 plus 17, which gives me 40, 16 plus 12, which gives me 28, 10 plus 8, which gives me 18, 4 plus 7, which gives me 11, 8 plus 9 is 17, and 11 plus 13 is 24. And so I can compare this up again. This is my blueberry bagels at my Main Street location. So their sum for week 1 and week 2, they sold 40 bagels. Okay. And I can compare that with each specific entry if I cared to. But here is what we were looking for, matrix addition. So same type of information, but I have a different question here. Okay, again, I'm focusing on week 1 in this problem. Assuming that the number of products sold at each store is the same for 3 weeks straight, how many units were sold at each store? Okay, well, if I have 23 units of blueberry bagels are sold at Main Street, and it's the same for 3 weeks straight, meaning how many total do I have there? So I would take my 3 times my 23. Well, same thing for this one. I would take 3 times this one, 3 times this one, so on and so forth. So this is an example of my scalar multiplication. Okay, I would be taking 3, because I have 3 weeks straight, times my matrix of 23, 16, 10, 7, 8, and 11. And so if you can do this simple multiplication, then you would be getting the answer here. And so we would be getting 63 sold here, 48 sold there, 30, 21, 24, and 33. So we can see that 63 dozen blueberry bagels are sold at the Main Street. That's what this one means, for a total of 3 weeks accumulative. 48 blueberry bagels were sold at the Ohio Street location for 3 weeks accumulative, and so on and so forth. So here's an example of scalar multiplication in our matrix format that is used in real life. Okay. Same information, another application is if the profit on 1 dozen blueberry bagels is $5 and the profit on 1 dozen raisin bagels is $6, find the total profit on these items at each store for the given week. So how do we fit that into this matrix math that we're trying to do here? Is it addition, subtraction, scalar multiplication, or is it actually matrix multiplication? So this here is going to be defining a matrix. So that's my profit matrix of $5 and $6. And I'm going to put it in the front, and I'm going to partner that up with this here. Because remember, this number of rows needs to match this number of columns. And so my 5 goes with my blueberry, and my 6 goes with my raisin. So this way, everything matches up correctly. All right, this is a 1 by 2 matrix. This is a 2 by 3 matrix. Of course, my inner dimensions match, and I'm going to end up with a 1 by 3. So I have 5 times 23 plus 6 times 7. I have 5 times 16 plus 6 times 8. And I have 5 times 10 plus 6 times 11. Maybe make these guys smaller. And then when I do this math, that's going to tell me the total profit for each item at each store. So I have 5 times 23 plus 6 times 7 gives me 157. 5 times 16 plus 6 times 8 gives me 128. And I have 5 times 10 plus 6 times 11, or 116. Okay, so we did that multiplication, but now what the question is what does that mean? What did we actually do here? What did we calculate? So what these numbers mean is that the total profit at my Main Street store is 157. My total profit at the Ohio Street store was 128. And my total profit at the 12th Street store is $116. And those are cumulative profits for both types of bagels, both the blueberry and the raisin bagels, all put together. So this one just tells us the profit at each store. So we see the applications of matrices, and we did quite a few examples here: addition, scalar multiplication, and actual multiplication.